Hi, it's Marin Brennan, back with another coding lesson for you. You may wonder, why am I wearing one of my favorite nerdy coding shirts? Well, that's because today we are going to load up on some fun and learn about conditional statements. Now, conditional statements are really powerful because they can make your projects interactive for the user and also allow you to create games and personalize the user experience. Pretty cool. Today, the first thing you are going to do is go to my I'm Flying Starter project and remix it. Studying and breaking apart someone else's code can be a very helpful way to learn. And in the coding world, we use the term open source to describe program code that is free for everyone to see, study, modify, and share in its modified form. The open source community is built on a culture of sharing and ideally respect. And Scratch is really the perfect example of open source code at work because the software is free to use. And when you share a project you built from your Scratch account, everyone can see inside and study your code. Now, other Scratchers can copy your code to modify it, comment on it, offer suggestions for bug fixes. A bug is an error or a flaw, failure, fault in your code. The open source nature of Scratch means you can learn from and experiment on the work of others. And Scratch calls a project that is copied from another Scratcher a remix. In the professional developer world, people also remix code. It's often called forking the code. So today you're going to remix one of my starter code projects to finish building a little Scratch flying game. And together we're going to program it to use the keyboard keys to move the Scratch cat around through the air and get some sprites to talk to each other. Let's give it a shot. This green remix button will appear on the screen if you are logged in. If you're logged in, simply click the green remix button, and it will make a copy of this project on your account and automatically bring you inside. If you aren't logged in, simply click the blue See Inside button to get inside and see the project. Now, when I first get inside, I'm going to click the green flag to see what this program actually does. Okay, so I see some buildings whizzing by. I see a bat and a butterfly flying along. The cat seems to be stuck in place. And I've added a few sprites and a backdrop. Let's take a quick peek inside this code to see what's going on. I'm going to click on the bat. Whoa, this code may look complicated, but don't worry, soon you'll be writing code just like this. But let's take a quick peek at what we see here and see if there's anything we recognize. For one, I see a forever loop. We learned about loops in the last lesson. This forever loop means I'm repeating some code over and over. And when I look inside the loop, I see some talk about next costume. If I click on the Costumes tab, you'll notice that this bat has two costumes, one with wings up and one with wings down. So if I go back and I look at my code, I can see that here I'm asking the computer to constantly change the costume from wings up to wings down. Right now, I'm going to click on my cat, and my goal today is to get this cat moving. I want my user to be able to control the cat by using the keyboard keys. So I'm going to start building in some scripts so that I can make the cat move up or down on the screen, left or right. To do so, I'm going to go over to my events blocks. In past lessons, we used when green flag is clicked. We also used when I receive when we were practicing broadcasting messages. Today I'm going to use a different input, when the space key is pressed. If I click on this little drop-down arrow, I'll notice I can choose from any of the keyboard keys that are here. I'm going to start with choosing when the right arrow key is pressed. I'm going to use this in order to make my cat move to the right when I press the right arrow key. In a previous lesson, we used the move block in order to move our character left and right across the screen. I'm going to add move 10 steps block to this right arrow key pressed, and I'm going to give this a shot. Notice that this particular script doesn't say that the green flag has to be pressed in order for it to work. So I don't actually have to click the green flag and start my program to test out this code. I'll just simply click the right arrow key, and I can see that my code is working. Pretty cool. There's just one problem with using this move block. If you remember from a previous lesson, the sprite can only move in the direction that it's facing. So what happens if I change the direction of my sprite? Now my sprite is facing toward the left side of the screen. When I hit the right arrow, I want it to move right. But it's moving left. To compensate for that, I would have to add another block here. I would have to tell it that when I press the right arrow key, I want it to make sure that the cat is pointing toward the right and then moving. Okay, so that works really well. But in some previous lessons, I mentioned that there are often more than one way to accomplish the same goal. And some blocks work similarly, but slightly different. For instance, we played with the sound block, start sound versus play sound until done. Well, today I'm going to try a different block that moves my character, but in a slightly different way. I'm going to scroll down to the bottom here and grab this block that talks about change X. What is X and Y? Let's take a brief moment to talk about X and Y Cartesian coordinates. Here I have a project I made all about Cartesian coordinates. If I was to give someone directions to my house, I would give them my street number and my street name, and then they could plug that into their GPS and find me. A similar system is at work here on our scratch screen, except instead of having a house number and a street name, we are giving the computer a point on an x-axis and a y-axis, and that tells the computer exactly where on the scratch stage my character could be. For instance, if I wanted to move my cat, you'll notice here I changed the position of the cat on the x-axis. The x-axis moves from the left to the right on the screen. I moved 50 pixels, 50 steps. And so now my cat is at x50. Dead center in the middle of the screen is x0, y0. Anything to the right of the screen is positive on the x-axis. Anything to the left of that point on the screen is negative on the x-axis. You can also move up and down. That is the y-axis. I am moving up by 50 steps. Now I am at x50, y50. Anything above the middle of the stage going up is a positive number on the y-axis. Anything moving down below the middle of the stage is a negative number on the y-axis. So let's get back to our cat flying. Let's switch out the point in direction and move blocks with the change X by block. And let's press the right arrow key to test this out. Excellent. So that's working just as expected. Just to check, let's change the direction of the cat again. When we had the move block in place, it had moved to the left when it was upside down, even when we were pressing the right arrow key. So we'd had to add the point in direction block and make sure that he was flipped over and pointing to the right before he moved. But now with the change X by block, when I press the right arrow, he moves to the right. Because change X and change Y doesn't care what direction your sprite is facing. It only cares about moving left and right on the X-axis and up and down on the Y-axis. So your character could be facing any direction you choose. Notice that my cat is way over to the edge of the screen. I can't even see him anymore. That's not really a problem right now because I could always click and drag the cat back to where I needed him to be. But the user using my game doesn't have that ability. In order to stop the cat from going all the way off the screen, I'm going to add one more block here. I'm going to add this block that says, if on the edge, bounce. Now let's see what happens when I move to the right of the screen. Excellent! My cat doesn't bounce off the screen anymore. Now that I know this code is working, I can duplicate it and use it for the arrows going in other directions. Code a little bit and then test, and code a little bit more and then test. This means if I find an error in my code, I might only have to change it once, and once I know that code is working, then I can repurpose it. So I'm going to quickly change the cat back to facing 90 degrees. I'm going to set up code for my other arrows. I'll get rid of this code. And in order to make the code for the left arrow, I am actually going to right-click and duplicate this whole script. Now all I have to do is change some of the values. For instance, instead of right arrow, I want left arrow. And instead of changing x by positive 10, because positive numbers go to the right, I want to change x by negative 10, because negative goes to the left. Let's test this out. Left arrow, right arrow. You'll notice when I hit the edge of the screen, my character actually flipped upside down. But I think that's pretty cool, because he's flying, so he can fly upside down. When I go back to the left, he'll bounce back. Keep in mind, though, it doesn't matter what direction my character is facing. When I hit the right, he'll go right. When I hit the left arrow, he'll go left. Now let's set this up for up and down. Again, I'm going to duplicate my code. But if I want to go up and down, I can't move along the x-axis. I have to move along the y-axis. So instead of change x by, I'm going to grab change y by. Going up is a positive number, and going down is a negative number. Okay, moment of truth. Let's test this code. Excellent. This all seems to be working just great. And now I can control my cat and make him interact with some of the other characters on the screen. This is great because I want to set up some code now that gets the cat talking with the other characters like the butterfly when they bump into each other. What you may not have realized is what we've created here with our code when the right arrow key is pressed, when the up arrow key is pressed, is we have been creating something called a conditional statement. A conditional statement is often phrased if something is true or false. So in this case, if, when the right arrow key is pressed, do this. If the up arrow key is pressed, when the up arrow key is pressed, do this. We can use conditional statements to create really powerful interactive projects. Using these inputs, when key pressed, is one way of doing that. But now I'm going to set up a conditional statement so that if the cat is touching the butterfly, something happens. I'm going to scroll over to my control blocks, and I see a couple of conditional statement blocks here. Conditional statements are often if, then, or sometimes the more complex if, then, else. Another option is to do something until. These are all conditional statement blocks. And you'll notice they are that familiar C shape that we saw with the loops. That means I can put code inside. So let's create a conditional statement with one of these simplified if-then blocks. The first thing I need to do is make sure that this block is connected to an input block because nothing runs if the computer doesn't know when to run it. So I'm going to grab another when the green flag is clicked. And I'm going to look more in depth at this block. I notice that there's a hole between if and then. It's got some sort of pointy shapes on the end. If I look through my blocks, I'll notice when I click on the light blue sensing blocks that there are a few here that are that shape. I'm going to grab the one at the top that says touching mouse pointer. I notice when I hold it close to that hole, the edges turn white. That means when I let go, it'll drop right in. Perfect. Now, I don't want something to happen if my cat is touching my mouse pointer. I want something to happen if it's touching another character. So if I click this drop-down arrow, I notice the other sprites are available. Let's have something happen if the cat is touching the butterfly. Now that I've got my condition in there, if touching is true, then what should it do? Let's have the cat change color. I'm going to go to my looks blocks, and I'm going to grab a change color effect by block. When I hold it close, it'll drop right inside. Okay, as I said before, one of the things we do when we're coding is we code a bit and then test. So let's give this a shot. I'm going to click my green flag since this condition will only work when the green flag is clicked. So here my cat is flying along. I'm going to be able to control him with my keyboard keys. So I'm going to run him into the butterfly. What should be happening is that the cat should be changing color, but it isn't. So something isn't quite working right here. I'm going to stop my code and run it again, just in case. Nope, still nothing. Now it's time to do some debugging. Debugging is when we look for the errors in our code. One thing that I like to do when I'm debugging is actually talk through my code out loud. Often when you talk through your code out loud, listing each step in order, you'll find where the error is. This is actually a funny coding joke where people talk to rubber ducks. It's called rubber ducky debugging. If you don't have a rubber duck, don't worry. You can talk to your computer, you can talk to a Lego, you can talk to anything you want. The point is to say your code out loud. So this code says, when the green flag is clicked, if I'm touching the butterfly, then change color. Did you hear what the problem was? The problem was this code says that the cat has to be touching the butterfly when the green flag is clicked. Since the cat wasn't touching the butterfly when I clicked the green flag, this condition wasn't true and the program stopped checking. What I want to have happen is I want the program to constantly check to see, is the cat touching the butterfly? Is the cat touching the butterfly? In order to have that program constantly be listening to see if this is true, I'm going to have to use one more block. It's a block we used last time, a loop block. I'm going to go back to my control blocks and grab a forever loop. I'm going to drop it here on my script area, grab my conditional statement, and slip it inside. Now what my code is saying is, when I click the green flag, forever see, is the cat touching the butterfly? Is the cat touching the butterfly? And the minute that condition is true, change your color. Let's give this a shot. There we go. Now that color change is happening a lot, so I might actually want to build in a small wait. Every time I change my code, I like to stop the code from running and then restart it, because sometimes it needs a little restart in order to adjust to the changes you've made in your code. So I'm going to add in a small wait, start my program again. There we go. Let's stop it with the cat touching the butterfly. One thing you may find is that sometimes something unexpected happens. Notice that my cat changed color when I started running the program. The problem here is that when the program ended, the cat was actually touching the butterfly when we stopped the program. So, because they are briefly touching at the very, very start, my cat might accidentally change color right away. So I want to build in a small wait here in order to make sure that my cat doesn't change color right away. Let's stop it with the cat touching the butterfly. Excellent. Now the program's waited just slightly, and so that the cat only changes color later on when I'm flying him into the butterfly. What I've done here is a bit of user testing. In professional coding development circles, user testing is done all the time. They ask other people to try out their website, their game, their app, and check for any issues they didn't think about. Okay, so this is fun, but maybe we actually want the butterfly to also respond to the cat when it's touching the cat. We can handle this a couple different ways, because as I've mentioned previously, in coding, often there's more than one way to come up with a solution. So one way we could set this up is to set up similar code here for the butterfly and tell it when it's touching the cat to respond a certain way. Another way we could handle this would be for the cat to broadcast a message to the butterfly. For instance, here I could add this little broadcast message block. I'm going to call this one bump. Now what I'm saying is, when the cat is touching the butterfly, broadcast the message bump. Then change its color, and then wait slightly before checking again if it's touching the butterfly. Now I can go over to my butterfly and use when I receive. and tell it what to do when it receives the message bump. Maybe that's play a sound. I'm going to grab this sound, hey. So I might want to build in a small wait. 1 second wait here. Now it'll wait 1 second before it checks again and starts broadcasting the message. Again, I'm going to stop and restart my code just to make sure that the computer's seen it. Hey. Much better. That again is a little bit of user testing. I can also use these same principles to get the cat to do something when it bumps into the bat. Another thing to keep in mind is you can actually put a conditional block inside of a conditional block. What I'm going to do is grab another conditional block. In this case, I'm going to grab if, then, else. First, what I'm going to do is I'm going to take this code out, and I'm going to put this conditional statement inside of the other one. Now I need my second condition. I'm going to go down here to my green operator blocks. You'll notice there's some blocks in here that also have that same diamond shape. I'm going to grab this one that says less than. I want to check to see, is the direction of the cat positive or negative? If positive, it's facing to the right. If negative, it's facing to the left. So I want to check to see if the direction is less than 0. And I'm going to go back to these blue motion blocks and scroll down until I see this oval-shaped one that says direction. Notice that oval shape fits right inside this circle. And again, if I hold it close, those white highlights let me know I can drop it in. So now I've said, check, are you touching the butterfly? Then check, is your direction a negative number? Let's have it do a color change. And let's have it do a size change otherwise. Let's give this a try. First, I'm going to run into my cat facing toward the right. So my direction is greater than 0. That means the size should change. Woo! Okay, that worked. Maybe I need to adjust it so that the size changes and then goes back to normal. Set the size to 100. Okay, now to test my code again. I'll scroll up so we can see what our code was. First, size goes back to normal. Now it's going to check to see if we are facing a positive or negative degree. Since we're facing a positive degree, the size should change. Excellent. You notice the flash when it goes back to its size after that 1 second wait. Okay, now I'm going to bump him into the wall so that he's facing a negative direction. He's facing upside down. Now when I ram him into the butterfly, it should change color instead of size. Excellent. If I bump him into the wall again, now he should change size. So now I've got something happening based on different conditions. It's checking to see first if it's touching the butterfly, and then it's checking for another condition. What direction is it facing? You can see how these can be super powerful as you are developing your games and programs. And it makes it fun because they're now more interactive for the user. I hope you've had fun today. Thank you for joining me.